Okay, in this video, we are trying to prove that cosine of x over 2 minus sine of x over 2, that quantity squared, plus sine x is going to equal 1. Now, a number of people have been asking how to do this kind of problem. So, first thing I'm going to notice is we have a quantity squared here. So, we're going to write cosine of x over 2 minus sine of x over 2, and we're going to multiply that by himself because it's squared. So cosine x over 2 minus sine of x over 2. So we're going to multiply those two together in just a moment. And then we have plus sine x equals to 1. So now let's go ahead and do this expansion here. We're going to multiply cosine times cosine, which is going to give us cosine squared of x over 2. And then we're going to multiply this cosine by that sine, which is going to give us minus, I'm going to write it as sine x over 2 cosine x over 2. And so that was, the first one was cosine times cosine. Then we had cosine times sine. And now we're going to have sine times cosine, and that's going to be a negative there. So we're going to have another one of these, minus sine of x over 2, cosine of x over 2. Now the last one we're going to have, we have done, let me just draw what I've done here. That was the first one. Then we had the second one. Then we had the third one. And then here we have the last one is minus sine times minus sine is going to be plus sine squared x over 2. Then we have this blue plus sine. Then we have equals to 1. Whew, okay, now we have a big ugly thing. Now what we're trying to do is make this left-hand side equal to 1. So it's not going to be too terribly difficult here. The first thing I want us to notice is that we have here cosine squared of x over 2, and here we have plus sine squared of x over 2. Now you have a formula somewhere on your formula sheet that says something like this: cosine squared x plus sine squared x equals to 1. Now, we don't have x's here, we have x over 2, but it doesn't matter as long as these two things are exactly the same. This is going to be true. So, let's get rid of this, and what we're going to now have is that this green plus this pink is going to equal to 1. So I'm going to write that down. Now I want us to consider these two pieces right here. These two pieces are actually identical to each other. So just like we have x plus x equals 2x, we're going to have pink minus yellow is going to be minus 2 pink times yellow, whatever that is. So we're going to have here, let me write it out like this, minus 2 sine of x over 2 cosine of x over 2. We have two of them, so we put the 2 in front, and they're both negatives. Maybe it'll help if you see it as minus 1 sine x over 2 cos x over 2, and another minus 1 sine times cos. By the way, you can see it here. I put brackets here. I didn't put brackets. It's up to you how you want to write it there. Then, after that, we have this plus sine x equals to 1. Alright, now, as I'm looking at this question, we want to make this side equal to 1. So that means this negative plus this positive are going to have to eliminate each other so that we can have 1 equals to 1. So how are we going to do that? Well, I am noticing that I have a sine here and that I have a 2 sine cos. Now, again, on your formula sheet, you are going to have somewhere there something that says sine of 2a equals 2 sine a cos a. Now here in this particular one, I want us to notice, this is a formula written on your formula sheet. I want you to notice that this is 2 of these guys. Well, with this formula, we don't have this in our equation. We don't have 2 sine A cos A. We have something that looks close to that, but not exactly the same. So let's just write what we have down here. We have 2 sine x over 2 cos x over 2, which is not exactly the same as that, but very, very similar in form. So what can we do then? Well, what we're going to do is notice that in this particular problem, a is exactly the same as x over 2. Well, what do we want? We want to know, what is this thing equal? This is what we have right here. We have this thing in our equation. So what is that equal to? Well, it's going to equal to sine of, what's 2a? Well, look down here. A is this, according to the formula sheet, is the same as our x over 2. So let's move this 2 over here. Move that 2 over there. That's going to make it say 2a equals x. So what's that going to mean? 2a here is going to be the same as x. Now, some of you wouldn't have needed to do any of this work. You could have just looked at the formula sheet and noticed that this one is twice as big as these. Let me say that again. This piece is twice as big as these, and that's how the formula works. So x is twice as big as x over 2. What's that in the end mean for us? That means we're going to come up here, we're going to write 1 minus, and instead of writing this big blue thing, we're going to write sine x. So sine x, and then we have down here plus this sine x equals to 1. And let me get rid of this stuff. You can rewind the video. You can go back on the video if you want to see that again. And so what does that leave us with then at this point? Well, here we have 1 minus sine plus sine, which means these two are going to cancel out, and so we have 1 equaling to 1. So that's how you prove, going back up here to the top, that's how you prove that that original guy is equal to 1. Now, there's another question that some of you have been asking about, and that is one that looks something like this. We have an equation that says prove that 1 minus secant squared x, or in the problem we're looking at, it's an alpha, 1 minus secant squared alpha times 1 minus cosine squared alpha is equal to 1 minus tan alpha with a squared up here minus cos squared alpha. So how are we going to do this? This, for some of you who are looking at a handout, this is question U. So how are we going to prove this? Well, again, we have a formula sheet, and that formula sheet can be very helpful to us at times. In this particular problem, what I'm going to notice is I have 1 minus cosine squared. Now, on the previous problem, we talked about how sine squared alpha plus cos squared alpha equals 1. Well, we've talked about in previous videos and in other previous times that 1 minus cosine, we could move this cosine over to the other side, and 1 minus cosine squared alpha is going to equal sine squared alpha. So I could come up here, and because of this light blue expression here, I could take that out and I could put sine in there. And that may be helpful for me. In fact, that could enable us to solve this. Another thing we could do is we could expand these brackets like we just did in the previous question. So there's not just one way to solve this, but since I've just noticed this right here, that 1 minus cosine squared a is the same as sine, let's go ahead and do that. We're going to have 1 minus secant squared alpha, and then this whole piece is going to be sine squared alpha equals 1 minus tan squared alpha minus cos squared alpha. Alright, so what can we do from here? Again, there's not a direct path, but I'm just noticing here that we could expand these brackets now. So if we did that, That's going to come to there, and this is going to come to here. So we're going to have sine squared alpha minus, now let's get some colors going here. This is going to be sine squared alpha multiplied by secant squared alpha. And again, let's get rid of this guy. Alright, we'll leave this side alone for a moment. So now what are we going to do here? Well, let's just write what we have. Sine squared alpha minus sine squared alpha multiplied by, this is 1 over cos squared alpha. And if it makes you feel better, you can put this over 1. That's fine. So what are we going to do now? Well, I'm seeing some things come together. Hopefully you're seeing some things come together too here. This is going to be sine squared alpha minus sine squared alpha over cos squared alpha. And I'm just kind of leaving this one alone because I don't really want to change that. And let's go ahead and bring it down just so we can see it though here. We're going to have 1 minus tan squared alpha minus cos squared alpha. Alright, we're trying to make this side look like that side. We're not far here. Notice, what is this? This is sine squared alpha over cos squared alpha. That's tan squared alpha. And let's just write this one here. So I have a minus tan squared alpha right here, and I have a minus tan squared alpha. That's kind of nice. Now, I have sine squared over here, and what do I have over here? I have 1 minus cos squared. Well, if you remember at the beginning of the problem, we talked about how 1 minus cos squared alpha is equal to the same thing as sine squared alpha. So sine squared alpha is the same as 1 minus cos squared alpha. And so now we just got to write things and make them look a little bit nicer. You might notice that we have the exact same thing on both sides. But in order to help us see it, I'm going to write it nicely. 1 minus tan squared alpha minus cos squared alpha equals 1 minus tan squared alpha minus cos squared alpha. So both sides are identical to each other, and we have completed that problem.